Hello everybody, today we're going to do some examples of perfect square trinomials, and then we're going to transfer that concept to a way to solve quadratics by what we call completing the square. But let's start off with this idea of perfect square trinomials. Now, you know you have a perfect square trinomial if you have a quadratic that has this format: a squared plus 2ab plus b squared. If that is the case, you can always factor it into simply a plus b quantity squared. And the key here is looking for perfect squares at the beginning and at the end. Alright, now it is possible that you could have a squared minus 2ab plus b squared, and in that case we're just going to factor it as a minus b. So the sign changes pretty much. Okay, look at number 1 here. We have a perfect square trinomial. Notice the perfect square here, and it's a minus. In order to solve this, all we need to do is take the square root of the first and the last. That gives us an x and a 3. And then the factorization is simply x minus 3 quantity squared. Look at number 2. We have a perfect square here and a perfect square here. 10,000, pretty big number. So according to the formula for perfect square trinomials, if we just take the square root here, we get x. If we take the square root here, we would get 100. So this factors into x plus 100 quantity squared. Alright, let's look at a couple more examples. Number 3 here, we have a perfect square right here and a perfect square right here. Simply take the square root. This factors into x minus 6 quantity squared. Notice the minus because we have a minus here. Now look at number 4, x squared plus 36. It kind of looks like the difference of squares, which is another lesson, but the fact that it doesn't follow that format, it is not factorable. We're going to call this prime. This is simply prime. Cannot be factored. Alright, let's look at another couple examples here. X squared minus 16x plus 64. Okay. Take the square root here, take the square root here. Notice the minus sign. We're going to have x minus 8 quantity squared. And then number 6, we're trying to figure out what is c if this is a perfect square trinomial. For c to work, it needs to be a square, and the way you find it is you look at this middle term, kind of like the b term of a quadratic trinomial, or just a quadratic, a regular quadratic trinomial. Notice the formula is for a standard form ax squared plus bx plus c, and if we're going to tell you that this particular quadratic trinomial is a perfect square, here's how you do it. You take half of b, which would be -7. You square it, which would give us a positive 49. And that's what c would be for this to be a perfect square trinomial. Alright, now we're going to apply this concept to a technique called completing the square. Okay, completing the square solves a quadratic, not by the quadratic formula, not by factoring, but by creating a perfect square trinomial, factoring it, then taking the square root. So there is a number of steps to this. First thing is we need to get all the x's to one side. And number 7 here, x squared plus 6x equals 15. All the x's are to one side, and so we kind of use the technique we just used on the previous problem. We create a perfect square trinomial. Let me write this again and leave a little bit of space. plus something is equal to 15. Okay, we're going to take half of 6, which is 3, and then we're going to square it, which is 9. But rules of equations, if you do something to one side, you got to do something to the other. Same thing to the other. Okay, so if I plus 9 on the left, I'm going to plus 9 on the right. Okay, notice on the left we now have a perfect square trinomial, which we can now factor to this, x plus 3, quantity squared. 15 plus 9 is 24. And then I'm going to work on solving this like I would in the equation where I take the square root. All right, so in order to get rid of the square, I take the square root, but I have to do it to both sides. X plus 3 is now by itself. And then I actually have plus or minus the square root of 24. Now I can turn 24, I can break it down a little bit, plus or minus square root of 4 times 6. I can take the square root of 4 but not 6, so here let me write everything again, simplified down. Plus or minus 2 square root of 6. And then I still have one more step to do to solve this. I need to take away 3 from both sides. Alright, so I'm going to write the final answer like this. X is equal to minus 3 plus or minus 2 square root of 6. Alright, and that's an example of how to solve by completing the square. Alright, let's try this again with a different problem. Number 8 here, x squared equals 10x plus 7. First step, get all the x's to one side. So we're going to take away 10x from both sides. So here's what we have. X squared minus 10x. I'm going to leave a space, still equal to 7. Then I take half of 10, which is negative 5, half of negative 10, which is negative 5, square it, which is 25. And then I need to also add 25 to the other side to keep the equation balanced. 7 plus 25 is 32. I have a perfect square trinomial on the left, and I can factor it into x minus 5, quantity squared. To solve this, next, I take the square root of both sides. So x plus 5, or x minus 5, is equal to the radical 32, square root of 32. Square root of 32 can break down into 16 times 2. And remember, it's plus or minus. Anytime you take the square root of an equation, you do have a plus minus possibility. Let's write what we have left here. Simplified, the square root of 16 is 4. So I have a plus minus 4, radical 2. Last step, add 5 to both sides. Alright, here's our final answer for number 8. X equals 5 plus or minus square root 4. Let me back up a little bit here. 4 square root of 2. Alright, let's do one more. X squared plus 20x minus 20. First thing to do here, this is not a perfect square. Notice perfect square trinomial 20, this 20 right here is not a perfect square. We need to get all the x's to one side, so the only thing we're going to do is add 20 to both sides. So we have x squared plus 20x. Leave a space, equals 20. I have to create a perfect square trinomial. I'm going to take half of 20, which is 10. I'm going to square 10, which is 100. And to keep the equation balanced, I need to add 100 to both sides. So we're over here, we're equal to 120. We have a perfect square trinomial, x plus 10, quantity squared. X plus 10. Okay, and then I can break 120 down into 4 times 30. See, when simplifying radicals, you always want to break it down into one of the factors is the largest perfect square as possible. And you'd think it'd be more than this, but 4 times 30, 4 is our largest perfect square. Let's simplify that a little bit more by taking the square root of 4, and we have plus minus 2 radical 30. Okay, final step. Take away 10. Here's our final answer for this. Negative 10 plus or minus square root, or 2 square root of 30. Alright, thank you for watching. Hopefully this is a good explanation of perfect square trinomials and completing the square.